Hi, my name is Andrzej. I look after the LLVM Flang team at ARM. And this presentation is about the new compiler driver for LLVM Flang. Let me start with a bit of context. So LLVM Flang is LLVM's Fortran frontend. It was merged into LLVM roughly 2 years ago, and then when it was merged, it had no compiler driver. Our team took the task of implementing one from scratch, and this presentation is about the journey so far. I want to emphasize that this presentation is about LLVM Flang. There's also Classic Flang. I'm not covering Classic Flang here. If you're interested, you can check the links on the slide. But please bear in mind, LLVM Flang and Classic Flang are two separate projects, though with many similarities. So when we started all this, we had some rough idea what we wanted to achieve. First of all, we wanted to reuse as much Clang as we could. Reason being, Clang is a very mature and very well-known, very well-developed project with a very familiar driver to the user, so why not just reuse it? We also wanted to make sure that the interface that we provide to our users would be consistent with what Clang has, so that it feels like one homogeneous toolchain. And related to this, we wanted to make sure that, for example, we don't contaminate Clang help with options which are Fortran specific, because it doesn't make sense. And same with Flang help. And it sounds easy, but it was actually quite tricky to achieve. And I think two other points are fairly self-explanatory, so I'll just skip to the next slide. When we started all this, well, basically, this has been my first compiler driver. Like, this is the first time I'm writing one, and I think it's been the case for pretty much everyone on the team working on it. I mean, you don't write a compiler driver that often. So there were a lot of unknowns, and we weren't sure about many things. And the way we approached it was by sending a lot of RFCs to many mailing lists, also to Discord, and making sure we reach out as many people as possible and get feedback early. And in some cases, we actually weren't sure whether the approach was correct, and I just put a quote from one RFC where we say, look, we might be making a lot of changes to LLVM and Clang. We're not sure whether this is the right thing to do, so please could you take a look and tell us whether this is the right approach. And it helped. It helped massively. We got a lot of positive feedback and a lot of guidance from the community. Otherwise, we also spent a lot of time trying to understand how Clang works, because we wanted to reuse Clang, and although there's documentation, we really needed some deep understanding how things are connected and how things are meant to work. So that took actually a lot of reverse engineering. And lastly, we wanted to implement all this upstream first, because prototyping downstream is convenient from a development perspective, but we wanted to make sure that what we provide is something that the community is happy with, and we wanted to get feedback as early as possible. And here's just a couple of diagrams to compare Clang and Flang, so you have a rough idea what the differences are. So these are different phases within each of the front ends, and you can see that Clang deals with multiple languages. It's a front end for C-style languages like C, C++, Objective-C. There's also RenderScript, OpenCL, SYCL, and probably a few others. The first intermediate representation is AST, followed by LLVM-IR, and that's then lowered to object code or assembly. In Flang, we only deal with one language, which is Fortran, which makes things easier for us for the frontend itself. But we also have MLIR as one of our intermediate representations, so there's this extra complexity. And we have parse tree instead of AST, but there are some similarities. I also wanted to highlight that when it comes to lowering to LLVM or translating between different MLIR dialects, what the frontends do, they actually drive bits from other sub-projects. So it's not like it's happening within Clang or Flang respectively. It's more like Clang and Flang are driving the libraries that do this kind of job. So we want to write a driver, and how do we do it? So I mentioned that we wanted to reuse Clang. Now, Clang means many things, different things to different people. It's a massive sub-project with different components which are sometimes a bit disconnected or separate. From our perspective, the key was the driver library and also the separation between the compiler driver and front-end driver, because these are separate things, and that's very crucial here. And I'm trying to hint that on the slide, so you can see two code boxes, one with Clang help and the other one with Clang CC1 help. the first one being for the compiler driver, the other one for front-end driver. And you can see the help message is slightly different, so there's a hint that you are dealing with a different tool, but it's not really that obvious, and it doesn't say it's compiler or it's front-end driver. So let's try to understand what Clang does, because that's what we were interested in. And at the top, you have two code boxes again. And first one is trying to compile a simple C file and using CCC print phases to see what phases are being run. And basically, the way Clang works, it splits the compilation into phases and then creates a command/job for every phase. So for a simple C file, you can see 6 different phases, and I think they're self-explanatory. So in principle, for each one of them, you should have a separate job. Now, when you run clang clang ## on the same file, you see only 2 jobs. Yeah, so ## will print the actual jobs being run, and it prints only 2 jobs. And the reason for that is because the first 5 jobs are being squashed into one. That's because the front-end driver itself can do all that for you. So there's no need for separate jobs. And you can, the links at the bottom take you to the code that actually deals with this squashing or folding. Now, important thing happens on the slide. Compiler driver, Clang, creates a job corresponding to front-end driver invocation, Clang CC1. And that's key. That's where you can see the separation a bit more pronounced into compiler and front-end driver, and they do different things. And this job creation for Clang happens in Clang CPP, and you can see a link on the slide. And we implemented something similar for Flang, and the file is called just Flang CPP. I think that's quite self-explanatory. But I think you're still not convinced that there are 2 different drivers. So here are some code snippets, and I just extracted the bits that are most interesting. So when you run Clang CC1, yeah, you just see Clang. That's just one binary. So when you run it, everything starts in driver CPP. That's where the main entry point for Clang itself is implemented. And when you take a look, what happens at the very beginning, the driver checks the very first argument. And if it's CC1, it forwards all the execution to CC1 main with all the arguments. And that's where the boundary is between compiler and front-end drivers. On one side, on the left-hand side, you have compiler driver. On the other side, that's the front-end driver. And once you're in the front-end driver, I highlighted 2 quite key hooks. One is compiler invocation create from args, and the other one is execute compiler invocation. Compiler invocation within Clang's front-end driver basically encapsulates your compiler invocation with all the command line flags, input arguments, macros defined on the command line. And create from args, I think it's self-explanatory. And same with execute compiler invocation, yeah? So this basically highlights, okay, in Clang, this is basically what you have to implement, these 2 hooks. So now, to confuse you a bit, this is from Flang's front-end driver. So it's Flang new rather than Flang, and I'll get back to it later. But you have the 2 hooks highlighted as well, as mentioned on the previous slide. And I'm showing you this because this structure is basically very similar to what you will find in Clang. In fact, you can go to Clang's front-end driver, open similar files, and you will see similar structure. That's because we felt that design in Clang front-end's driver is nice, and we wanted to reuse it, and also it means it's easier for people to switch between front-ends and try to implement similar functionality. To understand what happens in the front-end driver, I again highlighted a few interesting bits. So, for example, in this case, one of the first things that happens when you parse arguments, the driver looks for options that correspond to actions. In this case, I highlighted its parse syntax only. So then in execute compiler invocation, what happens, a front-end action is being created that corresponds to parse syntax only, which is basically F syntax only on your command line. And front-end action, another very important class within the front-end driver implementation. Later, through compiler instance, this front-end action is being executed, and you can see it on the right-hand side. And basically in there, you'll find one key loop that goes over all input files, and for each one of them, it runs begin source file, execute the actual action, and then end source file. And you'll find this structure in Clang, and this has been copied from Flang. Obviously, this is just the overall design. The fine details, the devil is in the details, basically. What the actions do, how they are implemented, how options translate to actions, how they interact with actions. All those fine details are completely different in Flang, and there's very little similarity, but the overall design is very similar. So to summarize, in order to write a new driver based on Clang driver library, you have to make a few things in Clang and then a few things in Flang. In Clang, basically, you have to specialize the tool class to create front-end driver invocations. So that's what we did for Flang. We also introduced Flang mode so that the Clang driver library knows that when dealing with Fortran input, needs to do a few things a bit differently because it's not C++ or it's not C or something like that. We also spent quite a bit of time in options.td, which is a table-gen file that implements all compiler options for Clang, Flang, compiler driver, front-end driver, and a few other drivers. So it's shared between pretty much all these tools. And that's where we had to make a few tweaks to make sure that, as you can see on the code box, Clang rejects Fortran options that it doesn't understand. This option is available in Flang, but it's not available in Clang. And we wanted to make sure that the behavior that the users see is intuitive and makes sense. In Flang, you have to implement the compiler driver itself, but that's just a thin wrapper around the Clang driver library. There's not much code to be written there. Most of the work goes into implementing the front-end driver itself, and I just highlighted the key bits. In there, it's split into compiler instance, compiler invocation, front-end options, action, and actions. And these are like key classes, and when you understand the relation between them, I think the overall design becomes very clear. And that's it. So what's the status of the new driver? This is the diagram that I showed you on one of the earlier slides with different phases within Flang. Also on the first slide I mentioned there was no compiler driver when Flang was merged into LLVM. Instead, there were 3 different drivers, F18, BBC, and TCO, driving different phases within Flang. Today we have Flang new FC1, which is the front-end driver, which can drive all these phases. On top of that, it can also generate object code and assembly, so it can drive LVM itself. F18 has already been removed from the repository, and we use Flang new instead. Now, it is called Flang new rather than Flang because when we started this work, there was a bash script called Flang in Flang repository. It's still there. Our goal is to rename it, to change it, but this is still to come. But more excitingly, Flang new can generate executables, and you can see example in the code box on the slide. So that's been a huge achievement, and that's actually from the last few weeks, I think. We've also been able to build Snap, which is a proper Fortran application, or actually a benchmark that we've been using also to benchmark Flang itself. There's a caveat, there's a few patches missing on main, so you may need to use the third dev branch, but I'm hoping by LVM 15 we'll be able to just use main. And I also added some links to the slide, you can use them. And also my colleague Mats has recently presented a paper at CGO LVM workshop on LLVM Flang, benchmarking LLVM Flang using Snap. And that's been very interesting and exciting, so I encourage you to look it up. I think it's already available on YouTube. And here's a summary of next steps for the driver. So we still don't have any optimization flags. So that's the next thing that we want to implement. And that's going to be a bit tricky because we have to define optimization pipelines. CMake support is something that's been in progress. So there's a patch, and I had some testing to do. So hopefully in the next few weeks, that's going to be merged. That's been tricky because of classic Flang versus LLVM Flang as well. We still can't consume MLIR files. We can consume LLVM files, but not MLIR files. So that's one thing that we need to add support for. And there are math runtime intrinsics, which is something that's very specific to Fortran and to Flang itself. And currently, for us, it means we have a dependency on an external project, which we want to remove. And that will require some work within Flang itself, but also within the driver. But that's only when you do use these intrinsics. This brings me to my key takeaway, which is, for us, being able to use Clang, I think it has been a massive win because it simplified a lot of things. We had a point of reference, which was very nice to have. And also, we have within LLVM 2 drivers which behave very consistently for very major languages, and I think that's been very nice. There's been a few challenges though. So I tried to highlight that we only wanted to reuse Clank driver library from Clank. So that's just one library, that's just one small component. Clank is massive and the driver library is not that big compared to everything else. So, however, for us it means that we have to build all of Clank whenever we build Flang, which is unfortunate. So we tried refactoring Clank and take the driver library out of Clank. We sent a few RFCs, and I think the community is in favor. But it's proved to be quite challenging, and after a few attempts, we decided to refocus on implementing new features in the driver itself rather than try to complete this. But I think it would be nice to do it at some point. And also, I think that would make it easier for other frontends to use the Clang driver library. I've tried to emphasize the split into compiler and frontend driver, and I think that's key from the whole design and also implementation side of things. And I think that has been confusing for users, but also definitely for me to begin with when I started working on this. And I think we could do better trying to document it or perhaps make it obvious that there's a separation between the two. Having one options.td file to share between so many drivers, I think that is also a bit perhaps not the best approach. Perhaps we should be splitting that into multiple files, again, to emphasize the separation between different tools. And also sometimes the semantics of the options are different depending on the driver. I mentioned also reverse engineering Clang, so trying to understand how Clang works, and that's been challenging. I mean, there's no other Clang driver-based driver inside LLVM apart from Clang itself. But Clang is a beast. It's massive. It accommodates for so many different use cases here. So trying to understand how it works, it's tricky. We did, along the way, re-evaluated some of our design principles. For example, we tried to maintain the G4chan compatibility mode, but it proved to be, oops, sorry for that. But it proved to be, I'll just finish without, so G4chan compatibility mode was already dysfunctional or switched off. And last but not least, we had some challenges trying to match the expectations of our users. And that's one reason being that we had 3 different drivers when we started, and we replaced that with 1. But 3 different drivers doing different things in different ways. And also, a lot of our developers come from classic Flang background. And that is, classic Flang is very different to Clank and LLVM Flang. And we've been trying to, make sure that everyone is very comfortable using the new driver. So I just wanted to wrap up and say that it's me presenting today, but it's been a team effort, community effort. We've got a lot of patches from various members and also people on in this audience reviewing patches. So thanks very much for that. And also, please send any patches if you want to make any changes or contribute. We're happy to help review and participate. Thanks very much.
Thank you. Are there questions? Any questions? Great.
So do you still plan to move Clank driver away from Clang, or is this, you said you're focusing Flang right now, but is this a project that you're still willing to do?
We still plan to do it. We are not focusing at it right now. It feels like, it's just a bit more productive trying to implement new things in Flang and prove that it's worth this. Because I think when we started, it was just a very small thing, and we saw that challenge, but it was like, well, nobody really is using it because it can't do anything. So we instead working towards a point where everyone is using it, everyone is happy with it, and that's the next big thing that is blocking people from using it. But it's not a blocker as now. I mean, it's not great, and we want to remove this dependency, but not today.
Our questions? I have a question. Do you have common options between Flang and Clang? And is that the design objectives that you share options?
Because of the way options within Clang driver are processed and created, there's really no option we have to share. If we have an option, for example, F syntax only, which is relevant in both, and you have both, there's little point in duplicating them. We would basically, there's...
Okay, cool.
Yeah.
Makes sense. Right, okay. Other questions? If not, let's thank the speaker again.